Hi everyone and welcome to MathSux. This video is going to help you pass the Algebra Common Core Regents. We're doing this one question at a time. Here's question 33. Michael threw a ball into the air from the top of a building. The height of the ball in feet is modeled by the equation h equals negative 16t squared plus 64t plus 60, where t is the elapsed time in seconds. Graph this equation on the set of axes below. So we have negative 16x squared plus 64x plus 60. So now we're just going to go to the table, go second, table, and look for the pattern. So this came up right away, which is nice. So notice we want to look for that parabolic pattern where there's numbers that are symmetric on both sides. So let's just write out the table we have here. We have x, y. We have 0, 60. 1, 108, 2, 124, 3, 108, and then 4, 60. So yeah, you go with, so this is a projectile motion question. So with these, you always want to start at 0, because the time, especially when it's dealing with time in seconds, so we're starting from 0 seconds and then moving up. So that's always what you want to look for when seeing these kinds of questions. So let's just graph this. We go to 0 and then we go up to 60, 1 and then 108 or about 108, so that's like about here, 2, 124, a little less than half, 124, 3, 108. So now it's got to be symmetric, so we want it to match the 108 we had at 1 second. And then 4 at 60 again. So we get this graph that looks something like this. Actually, we should graph all the way to the x-axis. So in order to do that, we're gonna estimate. See how it says 5, negative 20. So we know we don't have, it's not falling through the ground, but you can kind of just sketch it this way. Okay, so, and then label it. Okay, so we have the first part taken care of. Now let's look at the second part of our question. Determine the average rate of change in feet per second from when Michael released the ball to when the ball reached its maximum height. So whenever you see rate of change, we know we're going to be working with the slope. So we know we're going to be using the formula y2 minus y1 over x2 minus x1, because remember, it's always the rise over the run. So, but they ask for a very specific rate of change, because this isn't a line, right? This is a parabola, so we want to be careful about which coordinate points we're going to be comparing like this. So when Michael released the ball, so when he released the ball, that's right here, 0, 60, and then another point we want to look out for is reach its maximum height. So the maximum height is the highest y value, right? So that's right here, this 2, 124. So let's just bring those points down. So these are our coordinate points they want us to put into the slope formula. So we have 0, 60 and 2, 124. So now we just need to plug it into our slope formula. So this is x, this is y. So let's just do 124 minus 60 all over 2 minus 0. So plug this into your calculator and you'll get 64 over 2, which will give you 32 feet per second. And that's our answer. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!